in this question, we are asked to find the A, B, and C that basically make this rational equation true. So on the left here, we've got this fairly complicated looking rational expression with a really sort of heavy third degree polynomial denominator. On the right, it's broken into a sum of two terms where the denominator is simpler. So this is something called partial factor decomposition that's used in other areas of math. And just the idea is that we rewrite this messy combined rational expression into smaller chunks that are going to be more manageable for us to do other math on. So we're able to kind of go from here in this problem to solve for ABC by more or less just kind of using linear algebra techniques once we get our equation in the right format. So yeah, we've got a rational equation. We're going to deal with it just like any rational equation, and we're going to make it not rational. And we do that by multiplying by the least common multiple of the denominators. And in this case, that's x squared plus 2, 2x minus 1, because we can see that in all the terms. It should wipe everything out. So when I multiply through on the right, just remember we do have to multiply it by each term. And so when we do this, we'll get some cancellation. On the first one, it will cancel with everything. On the second one, we just have that x squared plus 2 on the bottom, so those are going to cancel. And on that last one, we just have the 2x minus 1, which is going to cancel. And now if I do the multiplication, I have x squared minus x plus 3 is our ax plus b, which is going to be multiplied by the remaining factor of 2x minus 1. And then the c is going to get multiplied by the remaining factor, x squared plus 2. And I'm just going to clean up the right side, get rid of those brackets, simplify. So I can use FOIL on this first one. It's just a binomial by a binomial. So the first will be ax by 2x. So I get 2ax squared. The outsides are ax by negative 1. The insides, b times 2x. And the lasts, b times negative 1. And then the other product is just going to be cx squared plus 2c. And so from here, to make this thing equal, the left side equal the right side, basically what we need to have is that the coefficients of each term on the left and right must be equal. So coefficients on the left equal the coefficients on the right. And in order to get that, what we'll do is regroup everything on the right for our x squared, x, and the constant so that we can see these coefficients. So if I factor on the right, I can see the x squared. I've got 2a plus c x squared for the two terms, 2ax squared plus cx squared. For the x, I've got negative ax plus 2bx, so I have 2b minus a x. And I've got 2c minus b left over for the constant. And this should be equal to the thing on the left. And so now, if I want to force the left side to be equal to the right side, it means that 2a plus c for the x squared has to match the coefficient of x squared on the left, etc. So we're going to match the coefficients. So for x squared, the coefficient on the left is 1, and on the right it's 2a plus c. For x, the coefficient on the left is negative 1, and on the right we've got 2b minus a. And we have the constant, which is, I usually just use a 1 to indicate the constant, but just so you kind of know what I'm talking about there, is I don't really see any 1s. But the constant on the left is 3, and on the right it's 2c minus b. So what we can do now is put this into a matrix. So I'll just use for my columns, so it'll be A, B, and C. And the first equation, I've got 2a, no b's, and a c. And the second equation, I've got 2b and minus a. Sorry, I don't need the b when I'm working in the column B. And the third equation, I've got 2 c's and minus b and no a's. And then it's 2a plus c equals 1. 2b minus a is -1, and 2c minus b is 3. And so we're going to do our row operations to try to cancel some things out. So I'm going to get rid of the 2 here by using the -1 below it. So I'm going to do row 1. It's going to be row 1 plus 2 of row 2. And that's going to give me a 0, 4, 1, and then 1 plus 2 of -1 will be -1. And I haven't done anything to the other rows. And then, so in this one, I basically use this to eliminate the 2 above it. Now what I'm going to do is use this -1 to get rid of the numbers above it. So I think the easiest thing is probably to do row 1 plus 4 of row 3, and row 2 is going to be row 2 plus 2 of row 3. That's probably going to get me to a place where it's pretty much solved. So I'm going to rewrite my row 3. And so I'm going to do this one plus 2 of row 3. So there's a 0. To add it to that does nothing. The whole point is canceling this. And then 0 plus 2 of 2 is 4. -1 plus 6 is going to be 5. And on this one, so I'm going to have 0 plus 2 of 4, of 0 is 0. The whole point is to cancel this one. And then 1 plus 4 2s is going to give me 9. And then I have -1 plus 12 is 11. And so I should be able to go ahead and solve. If I take this first equation here, this tells me that 9c equals 11. Therefore, c is 11 over 9. And then now if I take the next equation, this tells me -a plus 4c is 5. So -a plus 4 times 11 over 9 is 5. So I believe that should solve to give us a is -1 over 9. I'm not mistaken. Yeah. And then finally the last equation, kind of running out of space, but that's okay. I've got -b plus 2c is 3. So that's -b plus 2, and we've got that c again, 11 over 9 equals 3. Just running out of space here. I can shove that over a little bit. And if we rearrange and solve for that, that should give us that b is -5 over 9, I believe. Yeah. So we have solved for our 3 pieces. We've got a is -1 over 9, b is -5 over 9, and c is 11 over 9. And that would be the coefficients, and that will actually make those 2 expressions on the left and right identically equal to each other.